In this tutorial, we will be introduced to the three-dimensional structural formula. So in this formula, we will show a three-dimensional structure of the molecule. This is an example of a three-dimensional structural formula. Bonds coming out of the paper will be shown by wedges. So this bond is coming out of the paper, whereas bonds going into the paper will be shown as dotted lines. So these are going into the paper. So remember that we are showing here a three-dimensional structure, so we have to show those that are going out of the plane and those bonds that are going into the plane. So those that are going out of the plane, which is the paper or the screen, will be shown as wedges, and those which are going into the paper or into the screen will be shown as dotted lines. Let's talk now about reaction mechanisms. To be able to explain what happens in organic reactions, we will be considering the movement of electrons. Electrons are negatively charged, as we know, so they tend to move from areas of high electron density to more positively charged areas. So because of repulsion, these electrons will leave areas with high electron density, so we have so much negative charge, and they will be attracted to more positively charged areas. For example, if we have a lone pair of electrons, and these will be non-bonding electrons, they will be attracted to the positive end of a polar bond. So remember that covalent bonds are usually polar. So they will be attracted to the positive end of this polar bond, so towards the less electronegative atom. The movement of a pair of electrons will be shown by a curly arrow that starts from a lone pair of electrons to form a covalent bond, and it moves towards a positively charged area of a molecule to form a new bond. So this pair of electrons will move to a positively charged area, and thus it will be able to form a new bond. We will also be talking about free radicals. So sometimes a covalent bond, which is a pair of electrons shared between two atoms, may break in such a way that one electron goes to each atom that originally formed the bond. So for example, if we have two chlorine atoms, the bond between them will break, and each atom of them will take one electron of this bond. So these fragments of the original molecule will have an unpaired electron, and thus they are called free radicals, and they are usually extremely reactive. So a covalent bond will break, and remember that a covalent bond is a pair of shared electrons. When this bond breaks, each atom will take one electron, so it will have one unpaired electron, and thus it will become very reactive, and it is called a free radical.